All right, before I go into any of these questions today, I want to make something clear in this unit. When you write an answer down in this unit, when you find the probability of whatever I asked for, it should never be negative. Never get a negative answer. You can't have a negative chance at something. Some of you might think so, but all right, you can't have a negative chance at anything. Second thing, your answer should never be bigger than 1. This isn't like sports or music or the plays where give 110% effort. It's impossible. It's impossible. You can't give more than 100. And your answer should never be bigger than 100 or bigger than 1. Okay, so please keep that in mind. No negative answers, all right? And all your answers should be less than 1. All right, we all good there? Okay, let's dive into this now. There's 2 types of probabilities we're going to talk about. One's called theoretical. Here's theoretical probability. I'm going to flip a coin. What's the chances I get ahead? 50-50, right? 1/2. That's theoretical. What it should be. I roll a die. What's the probability I get a 2? What's the chance I get a 2 on a die? 1 out of 6 chance. Everyone agrees? Okay, so that's theoretical. What should happen? Experimental, let's say I go back to my coin. I flip it 20 times and I get 7 heads. My experimental probability of getting ahead would be 7 out of 20, not 1/2 anymore. Okay, so experimental is what actually happens when I perform it. Theoretical is what should happen. Okay, am I really concerned about the difference between the 2 at this point? No, I'm not. Okay, so again, experimental, you do a lot of trials of something and you base your probability off of the experiments you did. Okay, and theoretical is what it should be. All right, what it should be. 1 out of 6 for the die, 1/2 for the flipping the coin. We all good there? Okay, between the 2. Am I really too concerned about it? No. I want you to actually find these probabilities. All right, so real quick, and this got a little confusing last period, but I got a weatherman. He's going to say 40% chance of rain tomorrow. Do you know where that 40 comes from, by the way? When he does all different models and calculations that he does, that's where this 40% came from. So what type of probability did he use? Experimental, because he's doing all these trials, he's doing all these numbers, all right? That's his experimental probability. Because, hey, let's think of it. Theoretically, what should the chance be if it's going to rain? It's a yes or no, isn't it? 50-50. All right, so this is experimental. Chance of coins, 1/2. You get ahead. What type of probability is that one? That's theoretical. Yep, that's what should happen. Yep. Again, you'll only notice I have 2 questions on that. There's a reason. I'm not concerned about it. I just don't want you to start freaking out when you see experimental and theoretical. All right, let's get after it now. I got a die. Everyone familiar with a die? Okay, 6 sides. What's the probability I roll a 1 or a 5? Well, the first thing is how many 1s are on here and how many 5s. So that means you have a total of 2 possible choices for how many outcomes if I roll it once? 6. So 2 out of 6. That's your probability you roll a 1 or a 5, a 2 out of 6 chance. Now, I am not going to require that you reduce it, but I will warn you, most multiple choice answers are reduced. Okay, so just keep that in mind. I just want to make sure you're able to reduce a fraction. So 1 out of 3. What about I get an even, notation. Everyone see this capital P? Wild guess what it stands for? Probability. So probability, I can get an even number on 1 roll. How many evens are there? 2, 4, 6, 3 of them. Out of how many outcomes again? 6. So there is a 1/2 chance. Now, day 8, I'm going to keep, I have no idea what I just wanted to say. Harping. There we go. I'm going to keep harping on this. Bigger than 1? Everyone say less than 1, right? Less than 1 all the time, all the time. Any issues with that? That's basic stuff. We're familiar with that, right? All right, let's roll. Something a little bit different than just rolling a die or flipping a coin. You can read about your television programming. Watching a 30-minute show. And then 8 of those 30 minutes are commercials. So what's the probability, the chance that a commercial is not being shown now? Not being shown. I know 8 minutes are for commercials. That means how many for not commercials then? 22, right? 30 minus the 8. So 22 minutes out of a total of 30 minutes. Okay? 22 out of 30. Everyone see where the 22 came? Because I'm looking for not being shown. So the 8, I just used to subtract from 30. And then if you're reducing it, what's that, 11 over 15? All right, got it. I love these. They are wordy in this unit, but you gotta love them. All right, the background behind them. Juices sold in the cafeteria. And I don't want to be serious for the whole 40 minutes. Can we talk here? Where would your vote be? Wow. I'm just glad I'm not hearing tomato. That is, I don't know how you do stomach that. I don't know how you would stomach that. It's tomato. It's tomato. What? I like tomatoes, but not squeezed up and drinking, liquefied. No thanks. If you cared, probably not. Without a doubt, I'd be in the apple, orange, cranberry. Probably would go with orange. Put my vote in orange, but I would not even touch grapefruit or tomato. Not even touch. Grapefruit, see you later. And then when you start mixing it, well, what about the cranberries? No, we're talking straight up here. All right, talking straight up. All right, so Marcel's going in. He's going to pick a juice at random. What's the chance that he bought an orange or a grapefruit juice? Orange or a grapefruit. So here we go. How many oranges? 18. And the grapefruits? 7. That's a total of 25. And yep, you're going to have to do some calculation because the total always goes in the denominator. A 25 out of 40 chance. And this is exactly what I was talking about. I knew it was coming up. That's not a choice. Answer will be a choice, though. 25 over 40. Your calculator does it for you in your fraction template. I get so nervous. Never mind. I'll deal with it when the Regents time rolls around. Making sure we know how to use it. 5 out of 8. Yep, choice 4. So Marcel's got a 5 out of 8 chance of getting the orange or grapefruit. Any issues? Never? Really? It exists, yeah. It's awful. It's like sour. It's awful. It's awful. Okay, I was very surprised to hear this 5th period. You guys never heard of tree diagrams before, huh? Drawing out a tree diagram to list out all your possibilities. Most of 5th period were shaking their head. No, absolutely not. Okay, and regardless if you have or not, we got to still know how to do it. Okay, here's what we're doing. You got a coin, and we're going to flip it 3 times. And I want all the possible outcomes. So head, 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 tail, tail, tail. All the different possible outcomes right now. And instead of listing them out, we can draw a tree diagram to show all the outcomes. Here's how we're going to start. Coin number 1, ping, flipped. I got 2 more to go. What are my possible outcomes? Head or. So I'm going to start my tree diagram out by saying first flip could be a head or a tail. Second flip, ping, goes up. What are my possible outcomes? Okay, but ready? Let's say the first coin landed on a head. What are your outcomes for your second coin? So I'm going to do 2 branches off this one and say my next choice could be head or tail. What if it showed tails on the first flip? Same thing, right? I'm still going to go heads or tails. So this shows you all possible outcomes for 2 flips right now. Head, 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 tail, tail, head, tail, tail. Third one, ding, goes up. What if I got 2 heads on the first 2 coins? What could be next? Still a head or a tail. Now I'm going to branch each one of these off with a head or a tail. And if you count the last row of branch, that shows you how many different outcomes there are. So 1, 2, 3, 4, 5, 6, 7. There's 8 of them total. 8 of them. Now, some of you, probably not a big fan of the tree diagram, maybe. There's another way you can show all the results, and that's called the sample space, where you guys literally list out all the possibilities for me. All right, you're going to list out all the possibilities. So I'm going to use my tree diagram to do this. So I look over here. My first possibility is all heads. So I could go heads, heads, heads. This is called the sample space. All right, let's go around the room. Can I get 7 different people right now? The other outcomes. Langston, go. Heads, heads, tails. New. Jason. Oh, that guy. Remember, there's going to be 8 of them. So I'm going to get Mike. All right. Heads, tails, heads. Halfway home. Rachel. Heads, tails, tails. Already went. Put your hand down. Mary.
Tails, heads, heads.
2 more. Hi, Kylie. Tails, heads, tails. Yep. 1 more. Where is it? I got it. Dom. Nice job. So these are 2 different ways you can list out all the different outcomes. Through a tree diagram or through sample space where you actually list everything out, whatever you feel more comfortable with. Very rarely am I going to require you to do one over the other, but all right, be aware of both. Why do I like doing either one? Because it helps me answer probability questions like the next 3. What's the probability you get all heads? Well, how many times did all heads occur out of those? Once out of 8 different times. Yep. Exactly. Not more, not less. Exactly 2 heads. Count it up. Here we go. Did I miss any? So there was 3 of them out of the 8 possibilities. Everyone all right on that one? And then what about all heads or all tails? There's 2 of those, all heads, all tails, right there. Yep, there's 2 of them out of the 8. You can leave it like that or let it go to 1/4. Not too bad so far. The grind. What did I just say? 9 weeks from sitting down for that Regents. 9 weeks. There's no time. We'll talk. We'll talk. We'll talk. They're good movies. Don't get me wrong. They're good movies. First one, Hidden Figures. It's a good one. We'll sooner or later get into Karate Kid. The original. The original. You know, the Will Smith. No, not that one. No. The real deal one. Beautiful Mind. Pretty good. We got some good cinematic. All right. But you got to get there first. Got to get there. Got to get there. No, I don't. But if you don't put in the F, there's possibilities in here. Yes. Yes, absolutely. Yep, absolutely. What? I don't know. I don't know. Okay. I don't know. Look, I had 39, like I told you first day of school, I had 39 out of 40 get through last year, and that one still bugs the heck out of me, and it will for years. I guarantee it. So I'm going to try my best here to do even more. And I don't know if I could, but all right, it's going to bug me. All right, here we go. We're going to the carnival. School carnival, winners of the ring toss game. You can pick out of the prize bag. Look at this prize bag, huh? 2 sunglasses, 3 necklaces, and a keychain. John's the first one to win. Find the probability he chooses the keychain. All right, so how many keychains are there? 1 keychain out of 6 prizes. All right, don't overthink it. But he chose the sunglasses instead. All right, so the next winner that comes up, what's the probability they pick the keychain now? And yes, these will be different, and I want to know why they're different. There's still 1 keychain in there, but as far as prizes go, only 5, right? Because he kept the sunglasses. John kept the sunglasses at first. So explain why they're different. Why is it 6 and 5? 1 less outcome, right? Whack-a-mole would destroy everybody in this classroom.
In what?
Whack-a-mole.
What is that?
You.
Whack when you whack the mole. Pretty. Thing where you do the whole thing.
It's just here, and it comes. Pop, 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 pop. Done. Bells ringing. See you later, everybody.
So actually, I think I win in that game.
Yep. That's how I won the Hulk up there. 6 flags. Now, true, I beat a 7-year-old. That's fine. All right, but hey, he wanted to go toe-to-toe with the champ, so it was over. All right, go cry to your mama. All right, see you later. Whack-a-mole. Can't be beat. You get destroyed. Okay, I think we have 1 more. Yep, 1 more. And then you can finish the homework. Right now, some of these, like I said at the beginning, they're wordy. They're very hard to understand. Take a look at this one. You're taking a quiz. You randomly guess the answers to 2 multiple choice questions that have 3 choices. Now, before I even get into this tree diagram, I want to try to you guys visualize what's going on here. You have this quiz in front of you. How many questions are on this quiz? There's 2 questions, right? 2 questions. And you guys don't have to do this. You visually see this with me. There's 2 questions. How many choices are there for you? Okay, so I got a choice A you could fill in, a choice B, a choice C, and then question 2 also has an A, B, C. So is everyone seeing visually what this is going to entail? All right, so now let's try to make this tree diagram or sample space. Let's do a tree diagram. Represent the possible outcomes of guessing it correctly or not. Correctly or not. So let's go to question 1. How many right answers are there? 1, and the other 2 are wrong. Everyone agree? So the first way of my tree diagram is, what do you want to do? Correct, not correct, wrong, right? I don't care what we use.
Correct.
You want correct and not correct?
Yeah.
Okay, so I'll do C for correct, N for not correct, right? Here we go again. Question 1, how many are correct?
1.
And how many are not correct? Everyone see where that's coming from right now? 1 correct, 2 not correct. That's question 1. Let's go to question 2 now. Same thing, right? 1 correct and 2 not correct. How am I going to show that on my tree diagram? What if I got the first one? I picked the correct one. Well, I still got 3 options for my question 2, right? A correct and 2 not correct. And then what's going to come off of? I get messy with these, man. I got to work on that. I could do a correct and not correct. So do you see all your possible choices? All right? If you don't want to, you don't have to, but I am going to do the sample space here. I could do the first two correct. Right? Boom, boom, ding, got it. I could guess the first one correct and the second one not correct. Now, here's where kids get confused. Why do I have another correct, not correct? Isn't that the same thing? No, ready? Let's say choice A is the correct one on both. So I could go choice A and choice B. I could go choice A or choice C. That's this one. Two different ways of getting a correct and not correct. Everyone see that, where that's coming from? I don't want to lose you here. Yes, no? Okay. And then I could get the first one wrong, second one right. I could get them both wrong. And do you see how I could get them both wrong again? Ready? I could pick B and B. I could pick B and C. Both of them are wrong by choosing B first. And then next one. All right. Depending on what I pick first. Okay, I realize that a lot of you see, well, these are the same, but no, they're picking different incorrect ones every time in a different order. All right, so what's the probability you guess both questions correctly? Both correctly. How many are both correctly up here? Just one. Out of how many different ways could I guess them? 9 different ways. Yep. What's the probability of guessing only one of them correct? Go take your time, go through only one correct. So that's not going to work. I got 1, 2, 3, 4 of them out of 9. That's about as tough as these basic ones get here. Questions? Okay, take a look. You're going to finish it. Without no doubt in my mind, I'm going to finish this. I got the answer key right up here. All right, so let's get going. You can work with people around you. If you're confused about one of them, call me over. You're finishing it. You're finishing it. You don't have to worry about anything over